Hello, and welcome to Easy as Pie with Mr. Carpenter. I am Mr. Carpenter, and I thought we'd take this video and go over solving quadratic equations, because this is kind of the grand finale of the unit, where we take all that we know about quadratics, we try to solve their equations. And just as a reminder that whenever we are finding the solutions to a quadratic, what we are essentially doing is finding its zeros or its x-intercepts. So the word solution or root, zero, intercept, they all mean essentially the same thing, right? Where does this graph cross the x-axis? So when you see step one, right, it should make a lot of sense. It's make sure that the equation is set equal to 0. If the equation is not set equal to 0, then we're not allowed to use really any of the major strategies that we have available to us, right? So first things first, make sure the equation is set equal to 0. Then from here, the pattern is pretty straightforward. Step two, if we can factor, we will factor, right? There's kind of like a step 2a and a step 2b in a sense, because we're kind of break off in two directions. So step 2a, if we can factor, we will factor. And then step 3a, in a sense, would be split into two equations. Two equations. And we'll get into step 2b and 3b in a second. But first, let's just look at ones where we're able to factor. When I say factor, I'm talking about our three major methods, which is GCF, DOPS, and factoring trinomials, which I'll just do as FT. All right, let's tackle one right now. 3x squared plus 6x equals 0. Okay, first things first, is the equation set equal to 0? Yes, it is, so I'm all good there. If I can factor, I will, and in this case, I can factor, right? It is not a trinomial, so I cannot do factoring trinomials. There is not a minus sign in the middle, so I cannot do DOPS, so therefore, there has to be some kind of greatest common factor going on here. So what's the greatest common factor? Well, we have a greatest common factor of 3 and 6, which would be 3, because 3 is the largest number I can think of that goes nicely into both. And then they both also share a variable. They have an x squared and an x to the first. So I'll take the smaller of the two, which would just be x. Then I start my parentheses, and each term gets divided by the greatest common factor. So we got 3 divided by 3, which cancels out. And then x squared divided by x, which will just be x, right? We just subtract the exponents. 2 minus 1 is equal to 1. Plus 6 divided by 3 is 2, and x divided by x, those will cancel out, and I'm just left with x plus 2. I have a video on the greatest common factor as well, if you'd like to take a look at that. So step 2a is done, we have factored, and step 3a is to split into two equations. And what I mean by that is I have this piece and this piece being multiplied together to be 0. And the only way this happens is if either u are 0 or u are 0. So notice how I'm splitting into two different equations. So in this case, I can divide both sides by 3, and 0 divided by 3 is 0, so 0 has to be one of my solutions. And then over here, I can just subtract 2 from both sides, and 0 minus 2 is negative 2. So 0 and negative 2 would be my solutions. Okay, so that's a greatest common factor example. Let's look at a different one. Let's do 4x squared minus 25 equals 0. Okay, equation is set equal to 0. So I'm good there. Second thing, if I can factor, I will factor. You'll notice it's not a trinomial, so I cannot do factoring trinomials. And there's also no greatest common factor. So in this case, I'm going to look to see if I can do difference of perfect squares, right? You'll notice the square root of 4 is 2. So I can rewrite 4 as 2 squared. And the square root of 25 is 5, so I can rewrite 25 as 5 squared. And if you cover up all the squares, you'll notice that we have 2x minus 5. And we can pair that up with its best friend, 2x plus 5. And that would be difference of perfect squares taken care of. Once it's factored, I can split into two equations, right? So we got 2x minus 5 is 0, and 2x plus 5 is 0. Then, of course, I will add 5 to both sides over here. I don't know why I wrote a 0. Plus 5. So 2x equals 5, and then I divide both sides by 2. And x is 5 over 2, which would just be 2.5 if you like decimals. And then over here, it's going to be essentially the same thing, except now I just have to subtract 5 from both sides. So 2x is negative 5. Then I divide both sides by 2. And x is negative 5 over 2. And those would be my two solutions. So notice the pattern here, right? I look to see what factoring method I have to do. And then I factor. And then I split up into two equations. And even if you're factoring, there's some little mistake in there, right? You're still going to get a lot of the points on the question. Right, assuming you know how to break it up, and let's say you forgot to take the square root of 4, right? That would be a very minor mistake here, right? So really knowing what strategy, what factoring method to employ is very important, and that's where you should be devoting a lot of your time towards, so like finding this structure. Okay, here's another one. And I recommend watching all of these. Speaking of which, the secret word is bean sprout. Secret word is bean sprout. If I ask you what the secret word is, and you know it, then that would be in your benefit. Anyways, now we have this one. Equation is set equal to 0, right? If this was set equal to like 4, then I simply just have to subtract 4 from both sides and set it equal to 0, right? Do whatever I have to do to make sure that it's equal to 0. Okay? But for the most part, they'll start out equal to 0. And then I just have to factor, right? If I can factor, then I will factor. So there is no greatest common factor. It looks like 1 because they're both even, but you have to remember this is also something I have to consider, and that's a 1, so there's not really going to be any factors. They also don't share a variable, right? That 40 does not have an x. And it's not a binomial, so I cannot do DOPS. So I have to do my trinomial factoring. And when I do my trinomial factoring, what I'm going to do is I'm going to look for factors of 40 that add up to 14, right? Factors of C that add up to B. So in this case, and this is where you can just do some experimentation. For example, right, we know that 20 times 2 is 40. But 20 plus 2 is 22, right? I don't want 22, I want 14. So let's try something else. How about 10 and 4? You'll notice that 10 times 4 is 40, and when I add them up, 10 plus 4 is 14. So we're all set on that regard. I found my two factors. So how do I factor this? Well, it's always going to be 2 parentheses. X's go in the first spot, and the second spot just goes to these two numbers we found right there. So it'll be x plus 10 and x plus 4. Now we factor, we can split into two equations. X plus 10 is 0, x plus 4 is 0. And then, you know the drill by now. Some people from this point just like to flip the signs of the 10 and the 4. So x equals negative 10 and x equals negative 4. That's kind of like a shortcut. But I think it's nice to see the algebra at work as well. Okay. And that's pretty much every instance that you're going to find in these quadratic equations, right? If you can factor, then really what I'm expecting is either a greatest common factor, a DOPS, or a trinomial. And in every one of those cases, you're going to get 2 different sets of equations that you'll split into and solve each algebraically. Okay. The last thing I just want to hint on really quickly would be 2b and 3b, right? Step 2b is if it does not factor, right? So in this case, x squared plus 3x minus 5 equals 0. I can verify that there are no factoring methods that we can do here. There's no greatest common factor, there's no DOPS, and the only factors for negative 5 I have are 5 and negative 1 and negative 5 and positive 1, and neither of them will add up to 3. So I'm at a dead end with factoring. So cannot factor, right? You have to recognize it cannot factor. From that point, you have two options. You either have completing the square or the quadratic formula. And we already have a video on completing the square. So let's just tackle the quadratic formula real quick. In the quadratic formula, I have a, b, and c values. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. Of course, you do not have to memorize any of this. It will be given to you. And then you just fill in your a, b, and c values. So negative 3 plus or minus the square root of 3 squared minus 4ac over 2a. And that right there goes into your calculator. If you want the sufficient work for algebra, I do need to see this, right? If you just go chugging away in the calculator, I have to take off points. But if you show me this and then go chugging away in your calculator, then I can give you algebraic points. And this is also a good case to use that store button as well, storing values into a, b, and c, and then making that quadratic formula, right? Any of the problems before that looked like trinomials, you could have also done quadratic formula. They'll still give you the answers. But I find that knowing your factoring methods just helps you out in the long run. All right, and that is all for this one.